December question, rectangular pasture. So in this question, we have a 2D grid of different square cells. And in these cells, we have various cows at different locations. So the question is going to be asking for the different subsets of cows Farmer John can fence off. And what this means is if we have various cows at points in our grid, we want to find the number of different subsets of cows we can put rectangles around. So one thing I'd like to mention before we go into the algorithm is that this question kind of misleads you right here. So it kind of tells you that you should look for the cow sets that are not possible. However, since we know our answer can fit within a long, we can probably guess that the number of sets that are possible is less than the number of sets that are impossible. So what this means is that if we were trying to look for the number of sets that were impossible, it would be probably harder. So for our algorithm, we're just going to look for the number of possible sets. Okay, so before we get on to the actual program, let's look at how we could get to it. So I'm going to set an anchor point of here. So whatever fence I make, it's going to have to include this point. So I could move one here. We're going to sweep to the right. And I'm going to look over here and I could say, okay, well, this rectangle right here is going to be 1. And then I'm going to move on to the next point to the right. So I'm going to say, okay, for this rectangle, I could create this, or I could create this. And then for the final point here, we're going to say, okay, I could create this, or I could create this. So for this final point here, there's something important to note, which is that this point, when I'm creating my first rectangle, this point will inevitably be part of it. So I will never have a unique set of just this and this. And if we do a couple more examples, we can see there's actually a pattern or a very simple rule to this. And it's just, if I want a set that's going to include both this point and this point, if this point here is lower than this one, or closer to the first point, we're going to call this point 1 and point 2. This is going to be point 3. If point 3 is closer to point 1 than point 2 is, and to the left of point 2, then we are never going to have a set that includes point 1 and point 2, but not point 3. And there's a very simple reason for this, which is just, if I were to draw a straight line down from 2 to 1, this rectangle has to go through this point 3. So if I were to draw a straight line down, it would probably have point 3 be somewhere within the rectangle. So what this means is that as long as we have points that are to the left and closer to point 1 points, like point 3, then we know that we can't have a unique set of just 1 and 2. So why does this matter? We're going to look at the main example. So for our algorithm, what we're going to do is we are going to set an anchor point, just like we did in this case where it was point 1. We're going to set a point, and all of my sets are going to have to include this point. So from this anchor point, we could see I could create the set of this, and then again, we're just going to sweep this way. So I could go here, and then since that's the only point there, we're going to move to the next point in the sweep, and then we're going to say, okay, I could create this one, and then I could create this one, and then we're going to move on to the final point, and we can say I can create this one, and I create this one. And then what we're going to do to find all of the combinations is we are going to move on to the next point. And here we're going to sweep again, and then we're going to find this. And notice this also includes this point here. And then we're going to move on to this point. And then over here, we're going to do this. So right here is actually a very basic version of our algorithm. So we're going to sweep across all of the points, and then for each point here, I'm going to create my anchor point, and from this anchor point, I'm going to find and sweep again over to the other points. So yes, this is ON squared. So I'm going to find my second point, and I'm going to create the combinations of various points that include this point and my second point. So, like I mentioned earlier, if this point is slower or closer to my anchor point than the current point I'm on, then it's going to be included. So, reversely, what this means is as long as I am either farther away, so let's say again, we have point 1 here, point 2 here, point 3 here. As long as we have a point that is, say, above here, so let's say I have 0.5 here, as long as 0.5 is to the left of point 2, to the right of point 1, and it's taller than point 2, then it's going to create a new rectangle. So what this means is, since we know that a point like point 3, when passing through, will always be a part of this point, so I can't create a unique set, I know that another point like point 5 is going to create a new rectangle. So between these 2 points, we know that if a point is lower, then it's not going to create a new rectangle. But let's say if a point is higher, then we know it will create a new rectangle. So pause the video if you don't understand that bit, because that's pretty much the main fundamentals of the rest of the program. So knowing this, what we can do is we can actually realize that we can use this for our program. And there's another important thing, which is that if I were to draw a line out here, the points underneath the line and the points above the line are always going to create new rectangles. So what this means is, if I have this point here, if I put this point as my anchor point and this point as my current point, then I know that with this rectangle here and this rectangle here, because this point down here is going to add this extra section of depth here, we know that any point that is underneath here is going to create a new rectangle. So what this means is that for an anchor point and a main point, or a current point, we know that the ones that are in between them, so let's look at all the points that are in between them. If these points have higher y, or are further away, then they're going to create new rectangles. If they are closer, they are going to not create new rectangles, so they're going to be a part of the first rectangle. And if they are on the other side of the line, they're also going to create new rectangles. So even if I have a point right here, this is still going to create a new rectangle. So all the points, if I were to split this into a line, on the other side and above me, are going to be and create new rectangles. So this works on the opposite side too. So if I have a point here and I have a point here, then I know for this point right here, if I make this my current point, then all of the points up here are going to create new rectangles. So I could create one here, I could create one here, and so on. And I also know, since we're flipping it, this rectangle point is going to create a new point. So since this is closer, it's not going to create a new point, but since this point down here is further away, it is going to create a new point. So for any current point relative to the anchor point, any point that is either further away or on the other side of this imaginary barrier are all going to create new rectangles. So let's try this out with an example. I'm going to set my anchor point here, and then I'm going to create my rectangle here. I'm going to move on to the second point. My anchor point is still here. And I'm going to say I could create one here. I could create one here. So this point is actually wrong, because an important point in the problem is that no 2 points have the same x and same y. So we would run through a lot of complications if that were so. But since no 2 points share the same x or the same y, we know that points will either be here in the bigger than us group, here in the less than us group, or here in the under the imaginary line group. So all of our points are basically going to be greater than or less than us. They're not going to be the same. And basically what this means is, since there are no 2 same x and no 2 same y, it makes the problem a lot easier. So over here, I could create a rectangle here, and I could create a rectangle here. And if you solve this with a couple more examples, you'll find out that it does actually work. So this algorithm is going to be the main one we use. So just to review, we're going to split this. And then once we split from our anchor point, we're going to have the ones above, and we're going to have the ones below. And for any current point we're on, we're going to keep track of all of the points in between the anchor point and the current point. And of these points, if any of them are taller than me or further away from the anchor point, then they're going to be creating new rectangles. So we need to keep track of, say, a set of all of the ones taller than me so I know how many I can create. We also need to keep track of the number that are on the other side of the line so we can count that too. So in order to store this, we are going to need two various sets or lists. So we're going to need from this anchor point, all of the points to the right of the anchor point and to the left of my current point. We're going to keep track of the ones above this line, and above this line, since we're sweeping on the x side, it just means all of the values with y that are greater than my anchor point. And then we're going to have another set or list of points that are below the anchor point. So using these two sets, we can count how many are larger, we can count how many are smaller, and we can count our total value. So another thing that is really important to note for this calculation is, let's say I have a point here. So what we're going to do is, in this case, we would have point 1, point 2, point 3, point 4, point 5. So we would have two lists. So this is the list of above and this is the list of below. So in the list of above, we're going to add point 2, then we're going to add point 5, and then we're going to add point 3, and then we're currently at point 4. So over here, what's actually really important to note is for every point that can create a new rectangle in my above list, we can actually multiply this by the number of points in our below list. So this is just combinations, like creating various combinations. But for one point up here that I could create a new rectangle, for every single other point, I could create a new rectangle. So for this rectangle, I could create one with this. I could create one with this point. I could create one with this point. So for every rectangle point that I could create new on either side, I multiply it by the other side. So this is kind of confusing, but basically in the, let's say this is the x array and this is the y array. For every point in the y array that is greater than my current point's y, and for this we could use a binary search and just find the number of values that are greater. We're going to first, to our total, add this number. So we're going to add the number of points that are greater than me. This is just this group of here. And then we're going to add the group of points that is lower. So again, this entire group is going to create new rectangles. And then for every point up here, we could create however many points down here. So again, for every point up here, I can multiply all of the points down here. So every single new point here is going to create a new rectangle with this one point. So we're going to add to our sum x, we're going to add y, and we're also going to add x times y. So this is just because for every point here, we could create, let's say there are y points in here. So for every one of the x points here, we could create a new rectangle with all of the y points here. So what this is going to look like in program is it's basically going to look like we're going to loop through our anchor point, so this is going to be I, and then we're going to loop through our current point, which is j. And then we need to create this list right here. But what actually happens if I were to literally loop through every time and count the number of points that are taller and the number of points that are lower is we're definitely going to time out. So what we're going to do instead is we're going to use prefix sum. So the way we're going to use prefix sum is we're not going to use a two-dimensional prefix sum, but a list of one-dimensional prefix sums. So what this means is if I were to label all of these points, I'm going to create a list that's going to be 5 elements long, and for each element, I'm going to create a prefix sum. And what this prefix sum is going to do is I'm actually going to have two of these prefix sums. I'm going to have one for the ones above and one for the ones below. So let's say for this point 1, this is going to be this prefix sum list here. I'm going to create two prefix sums. One is going to be for the ones that are greater than me, and the other is going to be for the ones that are less than me. So let's assume this is the prefix sum for the values that are greater. In this case, what I would do is I would loop through. So I would have this point, and then I would say, okay, this is greater. So at index 2, it would be 1. And then I would go to 3, and that's less, so it would still be 1. Then 4, so that would be 2. Then I would reach 5, which is less, so it would be 2. And the reason we're doing this is that, so for this one point, we're going to have a prefix sum that would tell us, for a range, how many values are greater than this exact value. So when we're going to actually use this in our program, we're going to have an anchor point and a current point. We're actually going to be using the current points. So what this means is when I have a split here, when I want to find the points up here that are above my current point, I'm going to use the prefix sum for this current point here. And then when I want to find the points that are below, I'm going to use the prefix sum for my second point. So what we're going to do is we're going to have two prefix sums. We're going to have one prefix sum that's going to be greater or more. We're going to have one that's less. And each one of these is going to be size n. And for each one of these n dots or anchor points, we are going to have n values for the prefix sum. So it's going to be 2n different prefix sums. And I'll show you this more in the code. Okay, so the first thing we're going to do is we're going to create our data structures. So for this, we're going to have two data structures. We're going to have the more and the less, and these are going to be our prefix sums. So I'm going to resize them, and I'm going to put in the input. And then what I'm going to do is I'm going to sort the cows, and I'm going to create my prefix sum. So the reason I'm sorting the cows is I need to sort them by x, so I can sweep all the x to find my anchor points. And then what I'm going to do is I'm going to create a function called find that's going to find my prefix sum. So what this is going to do is it's going to loop over v being our anchor point, and then it's going to loop over I. And then for every value here, it's going to tell us, this is just a fancy way of saying, it's going to tell us if this value has a y that is greater than my anchor point's y. And if this point is greater, then I'm going to add 1. Otherwise, I'm going to add 0. So it's going to do the same, but the opposite for the less vector. So for more and less, they're going to be two prefix sums. The first index is going to be the anchor point, and then the second index is going to be the current point I'm on. So I'm going to call find, and then we're going to get into the actual program part. So we're going to say create our answer, and then we are going to loop through I, which is going to be our anchor point, and then j, which is going to be our current point. So the first thing we're going to do is we're going to add 1 to answer, because obviously we're going to need to create one rectangle every time. And then we're going to create two values called a and b. And what we're basically going to do is we are going to split it and see if it's in the top half or the bottom half of our imaginary line. So this is just the same line we were talking about earlier. So we are going to say if it is greater, if the y is greater, we are basically going to put it in, and we're going to create b and a. So we are going to use our prefix sums, and what we're going to do is we're just going to say for this one point, we're going to see how many are greater, and then we're going to find the range between I and j. So our first point is going to be the point that it's referring to. So I messed up a little bit in explaining this earlier, but it's basically going to be the point that we're referring to. So it's going to be like, we're going to compare all of the other points to this point. So this is just going to count the number of points from the first 0 to j plus 1 that are greater than our j point, and it's going to subtract this to find the number of points that are greater than j in this range. And then this is going to be the number of points that are less than j in this range. And we're going to do the same here. And since a and b, or x and y, are symmetrical, it doesn't really matter if we change up the variables. So we're going to add these values here. So these prefix sums are basically going to give us the point that are above us and the point that are below us. And then at the end, we are going to output the answer. And we're going to output n plus 1, which basically just means the points alone and the empty set. So the n is going to be all the cows by themselves, and then the 1 is going to be the empty set, and that's the end of our program.